Whether it is a slight breeze coming through your window or water passing through the pipes of our homes to enable us to shower, fluids are always flowing around us. The word fluid describes a substance that has the ability to flow. Gases and liquids fit this description, and that is why they are collectively called fluids. Such fluids have been channeled using spray cans, water hoses, pipes, and so on. The forces exerted by fluids have also been harnessed to help us do work and understand nature. These include pressure, which is the ratio of the weight of the fluid to an applied area, upthrust, which causes objects to float, viscosity, which is the internal friction between the layers of a fluid, and its close cousin, fluid friction, which refers to the resistance to the motion of a solid within or on the surface of a liquid. All of these have been explored in previous chapters. So in this one, let's take a deep dive into fluid flow, which is part of a larger area of study known as fluid mechanics. Let's start with the types of flow using water in a pipe. Fluid flow can be described as steady or unsteady. Steady flows do not change with time. If the water coming out of your kitchen tap releases 0.05 kilograms of water per second, a steady flow condition means this rate does not change no matter how long the tap is on. Naturally, an unsteady flow is the opposite. This changes with time. If you observe a solid particle floating in fast-flowing water, you would notice that the particle bobs and swirls as it moves within the liquid, changing direction constantly. This is known as turbulent flow, the kind that is common when you flush the toilet. In laminar flows, however, there is a lot more order. The word laminar refers to something consisting of layers. So particles floating in a laminar flow move parallel to each other, forming lines of flow which look layered. Streamlines are lines we draw in fluid flow to represent the direction of flow of a particle in that position in a fluid at a point in time. They are tangential to the line of flow. So in a turbulent flow, the streamlines change, but in a laminar flow, they remain fixed. By convention, when we draw streamlines close together, we are showing that the fluid velocity is high at that point. And when they are far apart, then the velocity is low. Flows may also be described as uniform or non-uniform, rotational or irrotational, one-dimensional, two-dimensional, three-dimensional, and so on. As a result, the flow can be described as a uniform, steady, laminar flow, for example. Alright then, let's bring it all together and summarize. We have learned that gases and liquids flow, and that is why they are called fluids. We also learned that there are different types of flow, such as steady or unsteady flow and laminar or turbulent flow. And we learned that streamlines are used to depict the direction of flow in a fluid. See you in the next class.